All right, so this is the Gravity and Orbits simulator type problem on positive physics, the inquiry one. It's where you deal with this. I'm just going to show you real quick, if you did not try it. I'm going to turn it to fast because we don't have a lot of time. But if we take the sun and we take the Earth and I hit play, how many Earth days should it take to get all the way around? 365. On a leap year, it's 366. What is that called? What did they call that in this lab? How long it took to get all the way around? It's called the orbital period. The time it takes to go all the way around is the orbital period. We call one orbital period for us an Earth year. Absolutely. So if I change the mass of Earth, let's try it. And I caught this a little late. But let's say I double the mass of Earth. Now it's a big old Earth. And we're gonna start it again. And we'll see how long it takes. It's a big old Earth. We're approaching halfway. Oh, about 180. Who wants to predict how long it takes? Let's see. We doubled Earth. It's getting close. Right there. Oh! Caught it right there. So, if I double the mass of Earth, does that affect how long a year is? No, it doesn't. I'll show you the math later, but it falls out. It does not matter. How can I change how long the year is? Move it closer or further away. Let's move it closer. Let's move it to about half the distance. It's going to be hot for sure. But you can see, bam. Oop, it took, well, we're going 2 revolutions now because I hit the button wrong. All right. Oh, gosh. Okay. So you can see it's gone around twice in less than a year. So as you get closer to the object you revolve around, what happens to the orbiting period? It's much shorter, right? So that is the effect. But the way we wanted you to see it in the lab here, and the way you should use Desmos, is what you can do is open up Desmos, you click this little plus. How many people have used Desmos in other classes before? Okay, you're probably a little familiar. What you can do is add an item and make a table. And that's the best way so you can graph your x and your y. I'm going to put the orbital radius, how close it is, on the x. And I'm going to use, my question was 4.96 atomic units. That's 4.96 the distance from the Earth to the Sun. So I'm going to choose some close ones. So I'm going to choose 1.52 as this x. And then the y is going to be the orbital period, 1.88. Okay. I'm going to choose one more, 5.2. That's going to be the closest one. I just click down here. I can create another one. Go up here. I create another one. 11.9. And then let's do this one too, just for funsies. And here we can see as we get a lot further away from the sun, the orbital period gets much, much longer. You can see Pluto here is 40 times away from the sun compared to Earth, and its year is 248. So it takes 248 years for Pluto to move around the sun compared to Earth. All right? So I put in these dots. And I'm going to zoom out so you can see all of them. And the other thing that I figured out that you can do is if you click this little thing right here, you hold down this, you can change and add lines between them, and that's going to help you figure out what your information is. So again, I just long held on here, and then I add the lines, and now it connects it, which is fine for what you need to do. So it said, my problem said, a student discovers an asteroid with a mass of this many Earth masses. Well, we found that the mass didn't affect it, but an orbital radius of 4.96 atomic units. So we're going to put this on our X, we're going to check that on the X, and see where that lines up on the Y. So if I look here, 4.96 is right about right here. If I move up to about where it crosses this estimated line, you can see, well, that's pretty darn close to over here that's 11. So my correct answer, at least a decent estimate of an answer, is 11 years. And that was correct for me. So that's what I'm hoping you do to finish up these answers. These are the two toughest questions on the whole inquiry thing. That's what I'm looking for you to do. Do I have any questions on that? Michael? Do you have 4.96 atomic units? Or do you have a different number here? You have a different number here. So you need to look on yours and extrapolate from your number. Because, positive physics is all different numbers for this reason. So you can't just cheat by checking what your teacher writes. So you check on yours, and you should be able to get a different answer. Okay? Any other questions? All right. I'm going to stop recording video. Let's stop.